So hello everyone. Today we are gonna solve another problem of CSES problem set, and the problem which we will be solving is building teams. And in this problem we are given n pupils are there and there are m friendships. That means a graph is given to us and we want to find out that whether we can divide the pupils into two teams such that no two team no two friends should be in the same team. So if there is an edge from 1 to 2, that means we can't put 1 and 2 into the same team. So by the tone of the problem we can clearly understand that it is a bipartite graph of problem where we have to color each edge from 1 to 2 in two different colors, after that from 2 to 3 in different colors, like that. And it is clearly stated that we have to print one or two depending on the team. Okay, so here if 1 2 is connected and then 1 and 3 is connected, so 1 is marked with 1, 2 and 3 are colored with 2, and there is 4 and 5. So there can be a case where the graph is not fully connected, so there may be different number of islands, so we need to take care of that case as well. So let's try to implement the BFS code in a bipartite graph. So we all know that we use BFS algorithm to solve it. So let me start by writing the code. First of all, we have to take the input as number of nodes and number of edges. After that, we have to take all the edges and let's just directly store it into an adjacency list. So we can say vector of vector and call it adjacency list of n size n plus 1, because it is a one based indexing graph, and there will be two parameters which we need to take. We'll take it afterwards. An adjacency of b dot pushback of a, and let's take two parameters here only. That's nice. And let's take the sample input and copy it over here. After that, we have to traverse through the graph and we have to color it. So let's take a vector which is called as color, and it should be of size n plus 1, and initially all are not colored yet, and once we color it we will mark it 1 and 0 accordingly. So we can start from 1 till n, and we'll call that if it is not colored yet, that is color of I equals to 0, then we will call BFS. So we can say it will call a function which is called as BFS, which will give true or false. If it doesn't traverse through whole graph, so it will return false. That is, if two simultaneous nodes have same color. So let's take an example. When it is a cycle of odd length, then let's say 1 2 and 3 are connected simultaneously, so 1 will be marked with 1, 2 and 3 are its neighbors, so it will be marked with 2. But when we reach to 2, it will say that 2 and 2 are connected and they both are of same color. So that's the case when we have to return impossible. So we all know that bipartite graph has a property that if it has an odd length cycle, we can't just color it, right? So let's call the BFS function, and it would require 3 parameters, and if at any time it returns false, then we have to, so we can just put it inside here as well. If our BFS function is returning false, you can just break out from the loop and you can just see out impossible and return from here. And if you complete the BFS and color everyone, so we can just print out all the nodes like this, color of I. That's it. Okay, and we just now need to write the BFS function. It is a boolean function and in start node, and we have to pass the adjacency list and the color array. Nice. And to run the BFS we would require a queue data structure, and we have to mark it that we can just use the color only. So color of start node would be marked with 1. Nice. And we have to push it into the queue as well, so that's cool. And we can just write if queue is not empty, you have to extract the first node, that is queue.front, and just pop it out. After that, traverse through its neighbors, and you can say that if its neighbors is also not visited, that is if color of IT is equals to 0, then you can mark it with the opposite color which is of the current start node. So you can say color of IT would be 3 minus color of that current node. So what it does is, if the initial color is 1, so 3 minus 1 would be 2, so its adjacent nodes will be marked with 2, and if it is marked with 2, then it will mark adjacent node as 1. So that's a small trick which you can use. And else if color of IT is equals to color of that node, means if two nodes are of same color, then we can say that it's an odd length cycle and we can just return false. And if this case never arises, then we can just return true. So that's all of the code. Let's try to run it. Let's see if it is running fine. Yes, it is indeed. So let's try and submit the code. And we can try to submit it. Choose file, this one, building teams, right, and submit. I think it should run fine. Yes, it is. So thank you so much for watching. Bye bye.